Thank you for the opportunity to be able to speak to you this morning. I'm going to cover off sustainable nutrition, this idea of moving from food security to nutrition security. But before I do that, I want to thank the conference. I was telling the ladies out in the back that this is the conference that has looked after me as a speaker the best that I've ever experienced in all the years of giving talks around the world. So thank you to them. I want to start by just thanking the team that I work with. You don't get to give talks like this without the efforts of a lot of people. And I particularly want to recognise Andrew and Nick, who are the engine that does the modelling that I'm going to talk to you about today. You know, definition of a sustainable food system, which is something that we need in terms of the globe, you know, so that's to ensure food security and nutrition for all. And that's the important bit, for all. And in a way that satisfies economic, social, environmental concerns in terms of achieving that. This is this ugly picture is a picture of the world food production system. You can't model this, it's too big. So the work I'll be talking about, the modelling we do, is inside this rectangular box. We work at the moment in kind of three horizons. So the first horizon is how do we feed the globe? And that's the model that we've had out for the longest. So that's the Delta model. We've updated that recently in that we now have inside that a cropping model. And what that does is it looks at all the land on the planet that can be used for growing food, okay? Which is different from all the land on the planet because not all of it can be used to grow plant foods. And later on this year, we're going to have another little model come out as part of it, which is about precision fermentation. So it models the resources needed to use alternatives to produce foods, such as, you know, the fermentation of dairy proteins. The other area we're now doing some work is in national models. So we're developing a model similar to Delta for Aotearoa, New Zealand, and we've also been contracted to do something for Kenya, and we're also involved in a number of others, including Norway. And then the final area that we're doing is a new model, and we hope that this will be ready by the end of the year. We call it IOTA. What IOTA is it's a model for you as an individual. So that if you want to make decisions about how you feed yourself, whether it's simply cost, or you're interested in cost and health, or you're interested in cost and environmental consequences of the diet you select, that's what IOTA will do. Right, I get to stand here for 2 minutes, whilst I play this animation, which tells you a little bit about the Delta model and what it does.
A challenge we face is our ability to sustainably nourish an increasing global population without exceeding the capacity of the planet. There are many different ways of approaching this challenge and many suggestions for what the answer may be. The Sustainable Nutrition Initiative, or SNI, developed the Delta model to generate informed discussion about food system sustainability. The model helps people explore changes to the food system themselves by changing components of the system and viewing the impact on the supply of nutrients. The model uses global food system data from international agencies and research to predict the nutrition available to the global citizen both now and in future scenarios. The user can adjust the production of different food groups, the degree of food waste, and the global population to see the impact of these changes on human nutrition. The model also calculates some of the other non-nutritional impacts of these changes, such as the amount of cropland required. The model has featured in multiple publications in scientific journals and has hundreds of users around the world. The SNI team has made the model openly accessible on our website so that anyone can have the chance to explore the global food system. This allows everyone to see the importance of considering nutrition when thinking about food system sustainability.
So everyone here can go on the website and can get access to the Delta model and play with it. It's really been set up with this nutrition for all which implies sufficiency for all. And it's really about modelling, as that video just told you. This graphic really is what underpins the model. So we look at the total food production around the world, and we use the food balance sheets from the FAO to do that. It takes into account losses from the system, such as feed for animals, the non-food uses of food products, and waste. And you end up with the food available for human consumption. And then using the USDA food composition databases, we turn that into the nutrients that are available for feeding us. And something we've added is bioavailability, right? Because the amount of nutrient you take in is not the amount of nutrient you get. There's a bioavailability function in there. At the moment, the only thing that we deal with from a bioavailability in the model is amino acids, and we're working on micronutrients. These are the mass flows that come from that model. So you can see that in terms of primary production, about 87% is plant-based and about 13% is animal source foods. Animal source foods includes eggs as well as animal foods, and it includes dairy. And then we take care of removing things like non-food uses, so that's feeding animals, etc., so that we can calculate the food that's available. Next is the food that we actually consume. And so you can see there that about 75% of the food that the global population consumes is plant-based, and about 25% is animal sourced. We can also have a look at total losses, and you can see that most of the losses, 91%, are in the plant-based foods. And if you think about yourselves at home, you don't generally throw away milk, you throw away lettuces. If you do that as a percentage, you can see that in terms of plant source foods, there's a big drop between the start and then food supply. So you go from 100% to 46%. So that indicates all the non-food uses of plant-based. Less of a drop in terms of animal source foods. And you can just follow those percentages down through that. So the model takes into account about 29 nutrients that are important to us, and then looks at where those come from in terms of the foods that we eat. And so here's a bar graph, it's color-coded, and we've just made some assumptions there about the types of foods. So dairy, eggs, meat, seafood, cereals, fruit and vegetables, and other plants, and looked at the various nutrients and how they distribute. So for example, you can see there that carbohydrates and fiber are almost entirely from plant-sourced foods, tiny little blue there for carbohydrates, which is an animal-sourced food. And at the other extreme, you can see vitamin B12, which all comes from animal-sourced foods. You don't get vitamin B12 from plant-sourced. It's a scenario model, and this was important to us. We didn't want to develop a model that created solutions, and we don't get into the business of telling people what they need to do. It's a scenario model that enables you to test what scenarios might be of importance to you. So our base, our start point is 2018, and the population on the planet at 2018. And so you can see here two macronutrients, energy and protein. The important line is the black line, right? That's the target intake. And so in 2018, with the food that was produced and the population we had, there was sufficient energy and protein in the world. Now, this model assumes equitable distribution. We can't model the fact that that actually doesn't happen, right? And one of the biggest problems with our food system is the lack of equitable distribution, right? So keep that in mind as I show you things. It's assuming equitable distribution. So here's a scenario. So we modeled the 2030 population, and we assumed that the same amount of food is produced in 2030 as is in 2018. The kind of interesting take-home here for these macronutrients and that black line is that even with those additional people in 2030, we're still producing enough energy and protein. to satisfy requirement. We've modelled out to 2050, same answer. We produce enough macronutrients to satisfy requirement if food was equitably distributed. The black line here is requirement, right? And here are the nutrients that the model deals with. And you can start to see some problems starting to arise. So in 2018, with the population then, the world had insufficient calcium and vitamin E to meet global requirement. Interestingly, if you look at the next series of nutrients that are close to the black line, they're all micronutrients. And when you start to move down and you start to look at the amino acids, which are the nutrients you source from protein, not such a problem, right? And this is a reoccurring theme. Micronutrients is what we lack. And when you look at that as a summary, 2018 gap, and then with the 2030 world population, but the same amount of food produced, you can see that the things that are showing up are micronutrients in terms of being in shortfall to world requirement. Some conclusions from this work. In terms of macronutrients like calories and protein, there's actually very few foods that provide the bulk. So in terms of calories, rice, wheat, milk and sugar. In terms of protein, wheat, rice, milk and pork. You can look at this for every nutrient that we follow. And there's a couple of examples there, but calcium, the major way of getting calcium in the global diet is milk. So there's a vulnerability and a dependency for nutrition security on a relatively few number of foods, particularly for micronutrients. We've done this for New Zealand, and again, 2018 data, and we looked at all the food we produced in New Zealand and all of our exports and imports to give us a balance. And in terms of macronutrients, New Zealand is fine, again, equitable distribution. But we have problems with a number of micronutrients, calcium, iron, and so on, which is interesting because in terms of calcium, for example, we produce 6 times the amount of calcium that the New Zealand population needs, but we have a calcium deficiency problem. Some summaries, it's not a versus story, right? It's not animal versus plant. It's about getting the right balance. And so plant foods responsible for the majority of supply of most nutrients, as you saw in that earlier graph. It's almost entirely responsible for carbohydrates, fiber, and a number of vitamins. And it's indispensable in terms of diets and the food system. You can't have a food system without plant-derived food. Animal source foods, highly important for delivery of several key nutrients, calcium, vitamin B12, and a number of the other vitamin Bs. The interesting thing is that generally provide nutrients in more digestible and utilizable forms. And so animal-sourced foods have a higher bioavailability for the nutrients they contain than compared to plants. They are dispensable from the diet of an individual, but they are not dispensable from a food system, right? So in terms of feeding the globe, we can't do it if we exclude animal-sourced foods. We have insufficient land on the planet to grow enough plant-sourced foods to feed the world's population. But you as an individual can choose not to eat animal products as long as you understand the consequences of that to your nutrition, and you need to make sure that you get yourself some vitamin B12, and you've got the resources to do it, because there are many studies that show that those diets are more expensive. Take-home message, the food system must be plant-based and animal-optimized. S and I believe that with a passion. We must attain a fully sustainable food system, that's vital. A healthy diet for one individual is not necessarily sustainable globally, right? So what you can eat as an individual is not necessarily what would feed the globe. Environmentally sustainable food systems, which is what a lot of people talk about, it's important, but they don't necessarily deliver adequate or healthy diets. So it's quite complex interaction here that you need to work your way through in terms of environmental sustainability, nutritional sustainability, and health. Thank you.